In this video, we'll write the Lewis structure for IBrCl+. So the first thing we do when we write Lewis structures, we count the valence electrons up. So each one of these atoms here, they're in group 17, sometimes called 7a, the halogens. They have 7 valence electrons. So we have 7 for each one of these. In the positive, that means we've lost an electron. So we're going to subtract 1. That gives us a total of 21 minus 1, 20 valence electrons for the IBrCl+ Lewis structure. Normally, we put the least electronegative element in the center of a Lewis structure. Here, iodine and bromine are fairly close. And since it's written this way, I'm going to just put them the order that it appears here in the formula, IBrCl. So we have 20 valence electrons. Let's put 2 between atoms. That'll form the chemical bond. Then we can complete the octets on the atoms on the outside. At this point, we've used 16. We have an octet for the iodine and the chlorine. We have 4 more, so we'll just put these on the bromine, and that completes the octet on the bromine. So this would be a Lewis structure for IBrCl+. This would be a good Lewis structure for IBrCl+. The formal charge would be 1+. That'd be on the central bromine here to match the charge on the ion. We would put brackets around it since it's an ion, and then we'd write a positive sign out here. For the molecular geometry, we have 2 atoms and 2 lone pairs. Let's look at that. So the central purple, that'll be the bromine. We'll add an iodine and a chlorine atom. They spread out. They give us this linear molecular geometry. When we add the lone pairs, though, they occupy space. They're going to push down those 2 atoms there, and that'll give us this bent molecular geometry. If we hide the lone pairs, we see it's a bent molecular geometry. The bond angle will probably be less than 109.5 since these lone pairs, they're going to push down a little bit harder than if we had atoms up here. If we wanted to talk about the electron geometry, that would be tetrahedral because we have these 4 steric groups here attached to our central atom. Back to our Lewis structure. If you use the AXE notation, A, the central atom, X, that would be the 2 atoms attached to the central atom, and E, the 2 lone pairs, and you looked AX2, E2 up, you would find it would be a bent molecular geometry for IBrCl+. This is Dr. B with the Lewis structure for IBrCl+. Thanks for watching.